All right, let's talk about unlocking a true SQL superpower, the subquery. Seriously, this is one of those skills that separates the rookies from the pros, so you're going to want to stick around for this. Just imagine for a second, what if one of your SQL queries was stuck, and it could just turn to another query and ask for a piece of information it needs to finish the job? Well, that's pretty much the core idea behind a subquery. So what is it really? A subquery is just a select statement that you nest inside of another one. But here's the secret sauce. The inner query, the one on the inside, it runs first. It goes off, finds an answer, and then hands that answer back to the outer query. It's like teaching your database how to think in 2 steps. Look, if you remember just one thing from all of this, make it this phrase right here. A subquery is a query that helps another query think. It's the perfect way to wrap your head around it. Okay, let's start at level 1. This is the foundation, the one you're going to see and use all the time. We're talking about the single value or single row subquery. Before we even look at code, let's think about a real-world example. Say you want to know if you got the highest score on a test. Well, first you have to ask a question, right? What is the highest score in the class? That question is your inner query. It finds that single number. Let's say it's a 98. Then you can take your score and compare it to that one specific number. See? Simple. And that is exactly what a single row subquery does. The whole point of that inner query is to return just one single value. That makes it absolutely perfect for those simple comparisons and a where clause, using all the operators you already know and love, like equals, greater than, or less than.
So where are you actually going to use this?
Oh, everywhere. Finding the one employee with the top salary? Check. Getting a list of everyone who earns more than the company average? Yep. Or just looking up a single value in one table to use as a filter in another? Classic, everyday stuff that subqueries make super elegant.
And hey, if you're thinking about a job in data, you need to hear this. A staggering 90%, that's 9 out of 10, of real SQL interview questions feature this exact concept. So mastering this isn't just a nice to have, it's absolutely a must-have skill for your career.
All right, you've got level 1 down. Let's move on up to level 2. What happens when our inner query needs to give us back more than just one single thing? This is where we learn to handle multiple results. The question we're asking gets a little bigger now. We're not just asking for the single best score anymore. Now we're asking for something like a whole list of top-rated restaurants. Or maybe we need 2 pieces of info for each one, like both its name and its rating. Now we've got 2 main flavors for this. First, there's the multi-row subquery. This gives you back a list of values, so many rows, but still just one column. You'd use an operator like in to check if something is part of that list. But then, there's the multi-column subquery, which is even more powerful. It can return several columns, letting you match records based on a bunch of different fields all at once. And the problems you can solve here get way more interesting. You could find all the employees whose job title is on a pre-approved list. Or, and this is a great one, with a multi-column query, you could find the highest paid employee in every single department. That's a much deeper, more valuable insight. And this is why it's so important. These aren't just for weird, obscure situations. Multi-column subqueries are absolute workhorses in data analytics, especially when you're building things like leaderboards or complex reports where you have to match data across multiple fields. Okay, deep breath. It is time for the boss level. This is where subqueries get really smart, almost like they're having a conversation with each other. Let's talk about correlated subqueries.
So check this out. You're no longer comparing an employee's salary to the average for the whole company. No. Now, for each and every employee, you're comparing their salary to the average of their own specific team. The number you're comparing against is different for every single row. And how does this magic happen? It's because the inner query actually references a column from the outer query. And this is the key. It means the inner query can't run by itself. It's completely dependent on getting a value from the outer query before it can do its job. It's a true partnership.
So how does the database actually pull this off? Well, it basically runs in a loop. The outer query grabs a row. It then passes a value from that row, like the department ID, down to the inner query. The inner query runs using that one specific ID, gets a result, and sends it back up. Then the whole process starts over for the next row, and the next, all the way down. This kind of power lets you solve some really complex problems. The classic example, of course, is finding employees who make more than their department's average. But you can do even cooler stuff, like using it to hunt down and remove duplicate records, or to find any departments that don't have any employees in them. These are tough business questions solved with one beautiful piece of SQL. Whew! Okay, that was a lot, I know. So let's pull everything we've talked about together into a nice, simple toolkit. A little cheat sheet you can use anytime you get stuck. Let's break it down one last time. If you're comparing against one single value, you want a single row subquery with your basic operators. If you're checking against a list of values, that's a job for a multi-row subquery with the in operator. Matching on multiple fields at once, that's multi-column. And for that fancy row-by-row dynamic logic, the correlated subquery is your best friend. And before we wrap up, a few pro tips. Please, please always test your inner query by itself first. It will save you so much frustration, trust me. Also, a quick note on multi-row queries. Any compares to the smallest value in your list, while all compares to the largest. And the big one, if your correlated subquery is running super slow, which can happen, see if you can rewrite it as a join. Often, that'll give you a huge performance boost. And that kind of leads us to our final thought. We've seen just how incredibly powerful and flexible subqueries are. They let us solve really complex problems with this cool, layered thinking. But they aren't always the only answer. And that brings us to the next big question on every SQL developer's mind. When is a join actually the smarter, more efficient choice? Something to chew on as you continue to level up your SQL skills. Thanks for joining me.